Day 562 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 404, sum of left leaves. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as well. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Given the root of a binary tree, return the sum of all left leaves. A leaf is a node with no children. A left leaf is a leaf that is the left child of another node. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples anyway, just to make sure that we are doing this problem correctly. So, in example 1, we have our input root, which equals a binary tree, 3, 9, 20, null, null, 15, and 7. The output is 24. The explanation says there are 2 left leaves in the binary tree with values of 9 and 15 respectively. So, let's just break this down one step further so we could understand what's going on, right? So first, this input right here is our binary tree. So as you can see, 3 is the head or the root node right here. Boom. Then we have a 9 to the left, which is right here, and a 20 to the right. Sorry, a 20 to the right is right here. Then you can see that 9 has no children to the left and no children to the right. So that's where this null comes from, because 9 has nothing to the left, and then this null comes from because 9 has nothing to the right. Boom. Then we're going down, and we're looking at the 20s nodes, children nodes. In this case, we have a 15 on the left, so that's 15, and we have a 7 on the right. What we want to do is we want to add up the sum of all of the leaf nodes, meaning a node with no children, that is to the left. Boom. So in this case, we look at 3, 9 is to the left. It's a leaf because 9 has no children, so that counts. That we're going to add that in our sum. Then we come down to 20. 20 we came to the right, but then from 20 we have more leaf nodes. So from the 20 we come to the left, and it's a 15, and this 15 is also a leaf node because it has no children, right? So it says a leaf is a node with no children. This 15 comes to the left, is the left child of 20, and then it has no children, which makes it a leaf node. So we're going to add this 15 into our sum as well. So we're going to use this 9 because it comes to the left right here, and has no children, and we're going to use this 15 because it comes to the left right here and has no children. So when we add 9 plus 15, we get 24, and that's how we got our output. Now let's take a look at example 2, just in case they might try to throw a trick question our way where there are no left leaf nodes. So in example 2, our input root equals 1. So just imagine we only have this node right here, and it's a 1. Nothing else is right here, right? And the output is 0 because there are no other nodes, right? We would just have this 1 right here, but there would be no other nodes right here. And since there is no nodes, that means there's no left node. And if there's no left node, that's why the output is 0. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all, so let's get into it. Now, the first thing we need to do is we need to initialize the sum that will hold the total value of all the left leaf nodes, i.e. our output, right? We need to store that somewhere. So to do that, we're going to come right here, declare a variable called sum, and we need to set that equal to 0 just to start. Then we need to create a depth first search helper function that's going to traverse the tree recursively, right? So we're going to come right here underneath this function, and we're going to say private, sorry y'all, it should be private func DFS, open up the parentheses, underscore, we'll say is left, colon, that's going to be a Boolean, comma, then we're going to say underscore is right, colon, that's going to be a Boolean, oh, excuse me, no, we're not even going to do it is right. We're going to say underscore node, because we're not worried about the right, so we're just going to just say underscore node, tree node, question mark, comma, underscore sum, colon in out, and that's going to be an integer. Boom. Then we'll come outside of these parentheses, open up the brackets, and we're going to create a base case. If the node is nil, then we can simply return. So we're going to say guard let node else, open up the brackets, and we could just return. Boom. Now, if the current node is a left child and also a leaf node, then we're going to add its value to the sum. We're going to do that by coming right here. We're going to say is left, comma, or sorry, not is left. If is left, comma, node dot left equals nil, and two and signs, node dot right equals nil, meaning if node dot left equals nil and node dot right equals nil, that means it's a leaf node, right? Because that means this side will be nil and this side will be nil. Boom. So what we're going to do is we're going to come right here, we're going to open up the brackets, and we're going to say sum plus equals node dot val, and then we're going to come underneath that and we're going to say return. Now we're going to recursively explore the left subtree, making these nodes as marking these nodes as left children. So we're going to come right here. We're going to say DFS, open up the parentheses. We're going to pass in true, comma, node dot left, comma, and sum. Boom. Then we're going to recursively explore the right subtree. So to do that, we're going to do the same thing, but for the right, we're going to say DFS. This time we're going to say false, comma, node dot right, comma, and sum, just like this. Then we're going to come all the way up here inside of this main function, and we're going to start our depth first search traversal from the root by saying DFS, open up the parentheses, false, comma, root, comma, and sum. We have to use the and because it's in and out parameter. Boom. Then we're going to come underneath this and we can return the sum by saying return sum. Sorry, y'all, I should say return. Boom, sum. Boom, y'all, that's all she wrote. Let's give it a run. Make sure it runs correctly before we submit it. It's accepted, so let's go ahead and submit it. Make sure it's still accepted. Let's see, and look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So before we go, make sure you get one more look at the code. This is the top part. Or actually, this is the whole code right here. So yeah, read it, learn it, love it. And I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.